Hello. So this is the second video in the differentiation topic, so chapter 5 or topic 5, and this one is going to look at the product and the quotient rules. It's worth pointing out in this one that we will be using chain rule as well, and where that's applicable, I'll be using the inspection method. So if you haven't watched the video on the chain rule that comes before this, if you don't know what the inspection method is for using the chain rule, then you might want to go back and watch that video first. So the product and the quotient rules are again expanding the repertoire of the things that we can differentiate. So they give us more types of functions that we can differentiate. Again, I'm going to assume you know how to differentiate basic functions, and like I've already said, I'm going to assume you know how to use the chain rule. So the product rule is for when we want to differentiate two things that are being multiplied together. So that would be my example 1 here, where I've got x squared multiplied by root 2x minus 3. That's what product means in maths. It means multiply. And the rule, product rule, it's in the formula booklet for the IB. So you don't need to memorize this formula, but you do need to be able to find it in the formula booklet and look it up. Similarly, the quotient rule is also in the formula booklet. The quotient rule is for if you're asked to differentiate something that looks like a fraction. So where you have a function of x on the top and a function of x on the bottom. So we're going to go straight into using these rules. I have got 2 examples, as you can see. And then I'm going to give you some questions to try yourself. So the first trick is identifying which of product and quotient it is. So again, you're looking for things that multiply if it's product rule, or a fraction looking thing if it's the quotient rule. So our first example is product rule. If I'm looking at the formula written above, we're going to call the first thing in our product u, and we're going to call the second thing v. It doesn't actually matter which way around you call them. I could have called the x squared v. It wouldn't have changed my answer. And you'll notice as well, with the v, instead of writing square root, I've chosen to write power half, because that usually makes our life easier for differentiation. So the first thing we want to do is differentiate both of these. So we're going to find du by dx, which comes out as 2x, and dv by dx. Now here we've got an application of the chain rule with that inspection method. So our outer function is a power half. We're going to do that first. Half comes to the front, minus half the power changes to, and then we're going to write 2x minus 3 in here. And then we want the derivative of the inner function, which is 2. We're going to multiply by that. And we can see there's some simplification to do. I've got a half at the front, a 2 at the end. They're just going to cancel out. So actually, we just get this. Once you've done that, now we just need to use the rule. So that's up here in the top right of my screen. Up over here. It says we want u dv by dx plus v by du by dx. What you'll see some people do is draw a little cross to represent that multiplication. So we want to multiply u by dv by dx. So we're going to multiply x squared by our dv by dx. So x squared 2x minus 3 to the minus half plus v du dx. So that would be 2x times 2x minus 3 to the half. And this is our derivative, so we need to make sure we write dy by dx equals. So it's very clear we found the derivative. There are ways to simplify this expression, but you're generally not going to be asked to do that. So I'm quite happy to leave this answer as it is. We can take a look at example 2. So in the quotient rule, it's important here, u and v, it does matter which way around you choose them. So in the quotient rule, u always has to be the terms on the top of the fraction, and v needs to be the expression on the bottom of the fraction. So u is the numerator, v is the denominator. So here u is x squared minus 3, v is 5 plus x. And we start off similar to the product rule. We differentiate both of our expressions. So du by dx is 2x, and dv by dx is actually just 1, because the derivative of 5 is 0, and the derivative of plus 1x would be just 1. Now, the quotient rule looks different, so this time we're following this one. It looks a little bit more complicated. You just have to take a bit of care when substituting the things in. So dy by dx is v du dx, so 5 plus x times 2x, minus u dv dx, so 1 times x squared minus 3. But be careful here, I've got a minus, which means I need to put that x squared minus 3 in the bracket because all of it is getting subtracted. And then over v squared is 5 plus x squared. It's fairly common in the quotient rule to want to simplify our numerator a little bit, but we don't need to do anything with the denominator. So what I would do here is I would expand the bracket on my numerator, 10x plus 2x squared minus x squared plus 3 all over 5 plus x squared. And then I can put some like terms together. We're going to get x squared plus 10x plus 3 over 5 plus x squared. So we've simplified the top a little bit. Usually in a question, if there's any simplification they want you to do, it will most likely be a show that in the exam question. So you know what you're working towards and you recognize, oh, look, I've got to expand these brackets because they've told me I'm supposed to get this answer. Okay. So like before, I've got 3 questions for you to try. So you should pause the video here and have a go at these 3. And then if you press play again, you'll see me go through the answers and you can check that you're correct. So we'll start with question 1. U is x squared plus 3. Du by dx is 2x. V is 5 minus x cubed. dv by dx is minus 3x squared. This one was product rule. The 2 things were multiplying. So for product rule, we're going to do v du dx, or u dv dx, sorry. So it's the yellow rule up here, u dv dx plus v du dx. So we're going to multiply this one with this one. And then we're going to multiply this one with this one. We could choose here to expand and simplify, but again, if they wanted us to do that in an exam question, they would have told us what the answer they wanted was, so that we knew we needed to do that. Second question. Actually, I'm just going to change. This was f of x. So if the question was f of x, I would have written f dash of x. So second one, again, we've got product rule because we've got 2 things multiplying. So we're going to call u the root x, and we're going to call v 2x plus 3 to the 7. Like before, instead of writing square root, I've put power half to make it easier for us to do our differentiation. And on the v term here, you've got, again, one of these chain rules by inspection. So dv by dx, we need to do the outer function first, which is a 7. And then multiply by the derivative of the inner function, which is 2. 2x plus 3 differentiates to make 2. And we get this. And then now our product rule, dy by dx would be u dv by dx. So I would probably write it in this order, although you won't lose marks if you do it in a different order, plus v and du by dx. And we've done with that one. And then finally, question 3. This time we've got quotient rule. It was a fraction, so u is 3x, v is 2x squared plus 5x minus 3. So du by dx is 3. dv by dx is 4x plus 5. And our product rule is, so this time we've got the green rule all the way up here. So v du dx minus u dv dx. So we're going to have 3 times this one minus 3x times 4x plus 5 all over v squared. And I could expand and simplify that, but I'm going to leave it as it is now. So that's the end of this video. You may want to practice some more exam questions on this topic. And the next one in the series is going to be on tangents and normals.